Hey, welcome. So, have you ever really thought about the ground you're walking on? I mean, really thought about it? Because it's not just dirt. Every single rock, every pebble has an absolutely epic story to tell. A story that stretches back millions, sometimes billions of years. Today, we're going to follow that incredible journey and uncover the secret life of rocks.
So let me just ask you this, straight up. Where does all this stuff come from? The pavement, the mountains, the sand on a beach? It all seems so solid, right? So permanent. But the truth is, it's in a constant state of change. It's always being born, then broken down, and then reborn all over again.
And that story, it starts deep, deep inside the Earth. We're talking immense heat, incredible pressure. It all begins with this, molten rock. We call it magma when it's underground. If it breaks through to the surface, we call it lava. This fiery, gooey liquid is the ancestor, the starting point for literally every single rock on our planet.
All right, so our story really gets going as this molten stuff starts to cool down. And this cooling process, it gives us the very first character in our story, the Igneous Rocks.
You know, the name is a total dead giveaway. Igneous comes from the Latin word ignis, which means fire. And that's exactly what these are. They're fire rocks, born from the cooling and hardening of that super hot magma or lava.
But here's what's so cool. It's not that they cool, but how and where they cool that changes everything. If the magma cools really slowly, deep under the surface, we call that intrusive. All that time lets these big, beautiful crystals form. Think of the granite countertops in a kitchen. But if it shoots out of a volcano as lava and cools super fast on the surface, it's called extrusive. The crystals have no time to grow, so you get these tiny crystals or even a glassy texture, like in basalt.
And this picture shows that journey perfectly. Look, you can see that huge chamber of magma way down deep. That's a batholith, where intrusive rocks like granite are slowly forming. But then you can follow the path of that magma as it pushes up and erupts from the volcano. That's where you get your extrusive volcanic rocks right on the surface. Two different paths, two totally different rocks.
Okay, but the story doesn't stop there. Not even close. Once a rock is formed and it's sitting on the surface, it has to face a whole new set of challenges. Wind, water, ice, you name it. And this brings us to our second character, the storytellers of the rock world.
For millions and millions of years, the elements are just relentlessly attacking these rocks. Rain seeps into cracks, freezes, and splits them apart. Rivers grind them down, wind blasts them with sand. This whole process of weathering and erosion can take the biggest, toughest mountain and break it down into tiny, tiny pieces, sand, silt, mud, which we call sediments.
So, how do all those loose little bits become a solid rock again? It's a process called lithification. It's pretty straightforward, really. First, all those sediments pile up in layers, usually at the bottom of a river or an ocean. Then, the sheer weight of all the new layers on top starts to press down, compacting them and squeezing all the water out. And finally, minerals that were dissolved in that water act like a natural glue, cementing all the little particles together to form a brand new, solid sedimentary rock.
And this is exactly why sedimentary rocks are so special. Because they form layer by layer over eons, they trap and preserve a timeline of Earth's history. And, get this, they are the only type of rock where you can find fossils. They are, quite literally, the Earth's history books.
And wow, what a diverse library of stories they tell. Just look at the variety here. You've got sandstone, which is basically an ancient beach turned to stone. You have limestone, which is made from the shells of billions of tiny sea creatures. You even have coal, which is just the compressed remains of ancient swamps and forests. Each one tells a completely different story about what the Earth was like millions of years ago.
But what happens if any of these rocks, igneous, sedimentary, doesn't matter, get dragged back down deep inside the Earth? Well, something amazing happens. It doesn't melt, it transforms. And this introduces the third and final character in our rock story. The process is called metamorphism, which literally just means to change form. And the key thing to remember here is that the rock gets cooked by incredible heat and squeezed by intense pressure, but, and this is important, it doesn't actually melt. It stays solid the whole time. It's like baking a cake. The ingredients change and combine into something new, but they never turn back into liquid batter.
One of the classic signs that a rock has been through this process is this beautiful banding you see here. That intense pressure literally forces all the little mineral grains inside the rock to line up, creating these distinct layers or stripes. Geologists have a name for this feature. It's called foliation,
And it's a dead giveaway that you're looking at a metamorphic rock like this one, which is called gneiss.
Now here is an absolutely fantastic, real-world example of this. You take limestone, that sedimentary rock often made from seashells, and you subject it to intense heat and pressure. What do you get? It recrystallizes and becomes marble. And that beautiful transformed rock is what was used to build one of the great wonders of the world, the Taj Mahal, an incredible transformation.
And here's another amazing change. On the left, you have shale. It's a pretty soft sedimentary rock, basically just compressed mud. But put that shale under intense pressure, and it transforms into the rock on the right, slate. It's much harder, it's durable, and it's a complete change in character, all driven by that immense pressure deep underground.
Okay, so we've met our three main characters. Igneous, born from fire. Sedimentary, built from the pieces of the past. And metamorphic, totally transformed by heat and pressure. But how do they all fit together? Well, this is where the entire story comes full circle.
This right here, this is the master plan. It's the rock cycle. And the most important thing to see is that it's not a straight line. It is a constant, endless loop. No rock gets to stay the same forever. Every single type can be changed into any of the others.
Just follow any of the arrows. A volcano spits out igneous rock. That rock gets worn down by the rain and wind into sediment. Those sediments get buried and squished into sedimentary rock. If that rock gets pushed even deeper, the heat and pressure bake it into a metamorphic rock. And if it goes deeper still, it can melt back into magma, and the whole cycle is ready to start all over again. It's basically the planet's ultimate recycling program.
Now, all this might sound like some huge, abstract process that happened millions of years ago, but it has a very, very real impact on our world, on our history. We have used these amazing materials to literally build our civilizations. I mean, just look at the incredible red fort in Delhi. It's built almost entirely out of red sandstone. So when you look at those massive walls, you are literally seeing an ancient sand dune or a prehistoric beach, compressed and glued together over millions of years that was then carved into the building blocks of an empire. How cool is that?
So just to bring it all home, this table is a perfect little summary of those key transformations we've been talking about. Igneous granite becomes the banded gneiss. Sedimentary sandstone becomes super hard quartzite. And like we saw, limestone becomes marble, and that soft shale becomes hard slate. It's just a powerful reminder that every single stone has this hidden potential for change locked inside it.
And that really brings us to the final thought I want to leave you with. The next time you're out and you just pick up a random rock, stop and think about its incredible story. That simple stone could have been molten lava deep inside the earth. It could have been the peak of a massive mountain or the sandy floor of an ancient ocean. Its story isn't finished, so the real question is, what will it become a million years from now?